Hello, everyone. Thanks for being here. Today, mostly what I wanted to share, this is not so much a sales pitch for an instrument, but it is just a technical talk on what we have observed after collecting over 500,000 scans non-destructively of various fruit commodities, and why large-scale representative data is going to be fundamentally changing how the fresh produce industry is understanding maturity and quality and post-harvest performance. Here we go. If you're not familiar with Felix Instruments, we are a company based out of Camas, Washington, in the United States. We have been in the industry for now 15 years, serving the post-harvest and fresh produce industries with real-time gas analysis and non-destructive measurement tools. We engineer, design, and manufacture everything at our headquarters in Camas, Washington. And our instruments have been deployed globally across orchards, packhouses, ripening rooms, and retail outlets all over the world. So why we're talking about this now is that we're seeing a lot of pressures converge on the produce supply chain at all stages. These pressures come from increasing demands for high yields, for increasing consistency in fruit quality, and we have consumers that are a little more preferential. They are expecting a lot of high quality fruit, and they are very good at identifying lower quality fruits and those failures in the supply chain. And so what we're dealing with here are issues that can't necessarily be resolved by using traditional quality control methods. Those methods are not necessarily scaled for matching the fruit variability. You can't really see all of those significant changes in variability across the different stages of the supply chain. And so what we want to do is talk about representative data and why that matters. A little background on our instruments, just so you understand how we got this data, how we understand this entire idea of fruit quality is our F750 produce quality meter has been out for about 12 years now. It is our original general purpose near infrared spectroscopy platform that is typically used by researchers to develop customized models, very tailored and specific for certain use cases and applications. But what we did from developing that is we started moving into commodity specific modeling situations where we developed a platform that is already ready to use out of the box. It is a commodity specific turnkey solution. So if you have avocados or mangoes or kiwi fruit or table grapes, those can all be measured with the click of a button in a matter of seconds, and you get internal quality attributes, things like dry matter, Brix, acidity, things that you would use to tell the maturity and the quality of your fruit. Now, the 500,000 scans that I referenced earlier, those all come from us and our building our global calibration data sets for our F751s. They come from customer modeling projects where we've worked hand in hand with individual users and research institutions and government entities to create models, and also our own internal R&D projects. And when we do this, we create these really diverse data sets. We make sure that we're getting data from all over the globe at all stages of maturity, at all stages across the supply chain. So we've seen data at every possible stage across every possible region. And so we have a really good understanding now of what the major issues that we see when people are doing their traditional QC testing. Now, a little bit about variability first is that all of the decades of peer-reviewed research show that there are many layers of variability, you could say. So we have a kind of a macro level, which is something like tree-to-tree variation within a single block, or even differences between orchards in the same region due to microclimates, soil differences, things like that. We have a meso level of variability, which is more on a single tree where you have strong canopy position effects. So if you have a fruit that's on the outside of the canopy versus the inside of the canopy, you're going to see different development of dry matter and other internal quality components. And then we have the micro level. So this is something that's not so often understood, but on the micro level, the actual spatial distribution of certain analytes is not homogeneous in most crops. And so the limitation here is that a lot of quality control testing will focus on smaller destructive samples because it is a destructive process and you're going to be losing your commodity. It is a laborious process, oftentimes involves trained personnel. But when you're doing that testing, you're also not necessarily concerned about understanding the entire spatial heterogeneity of that distribution of that analyte of interest. And so that's kind of what we're dealing with at this stage right now. And unfortunately, that variability can result in a lot of negative consequences. And those consequences come in the form of uneven maturities across your lots, which results in very ripening. You have different levels of ripening in the same lot. And that can lead to a lot of complaints from your customers that some of your fruit is over mature, or it's lost its ripening, or it's even had failures due to disease or due to internal defects. And this results in this kind of thing that we've encountered from a lot of consumers, which is this fruit lottery experience. When they go to the store to buy fruit, they don't know if they're going to get something that's good or something that's bad. The key metrics that are typically being measured when we're looking at the quality of a fruit is something like dry matter. That's more of a maturity index when you're in the field trying to determine when to harvest. Also helps to understand when you're going to be storing the fruit, how well it's going to hold up during storage. We have Brix, which obviously a lot of you know is the sugar content or an analog to sugar content. Acidity is more of a consumer preference thing. So that's for berries and grapes when people will need a good balance between sweetness and acidity. And then obviously things like internal color, firmness, and then obviously ethylene being a important gas for measuring when you're doing any kind of ripening or storage solutions. Now these metrics are super useful, but when you don't actually implement these in the sense of getting representative data, and you don't have that variability in mind, it's not going to really give you that much information in the long run. So what we see, the biggest issue that we see is that most QC data sets are a normally distributed data set, and they are very centered on the center of this curve. And all you see is the most important, we have a bunch of data on the average right in the center of this curve, and it all looks decent. But that's when you are doing small sample sizes. Now, unfortunately, the extremes of this are often neglected because they're not sampling high enough quantities. And so the extremes, when you're actually looking at, for example, let's say there's a lot of avocados that came into your pack house, and you do 5 avocado samples to understand the quality of that lot. In that case, those 5 avocados they're likely going to fall within that first standard deviation of that normal distribution. Unfortunately, maybe half of those avocados that weren't in that testing group are in those extremes on the outliers of the low and high dry matter, let's say. Now, those are what's going to cause you all the issues later on in the supply chain with storage and transport, and at the end consumer level when they're trying to pick a good avocado that tastes good and has good oil content. So these extremes are disproportionately driving those losses. And those losses have very real economic impacts. So those economic impacts are published. We have a lot of public data that show that. Us personally, we have talked to many retailers that have stated things like a single commodity loss in a year of $20 million. And so obviously we need to address this and figure out how we can get better data, more representative data, and use that to our advantage to increase the quality of our produce across the entire supply chain. And that's where non-destructive testing and near-infrared spectroscopy come into play. So with non-destructive testing, you can do high volume, rapid screening, and those large data sets will allow you to understand and make better big data decisions, the variability within your lots or within your orchard, whatever your standard organizational structure is. But basically what it's going to do is allow you to reveal that the full distribution of maturity. And with that information, you can then make better decisions. You can divide up your lots by better maturity standards, and you can reduce all of the barriers associated that normal destructive testing would have caused you with trying to do that level of testing. So the F750 and the F751 were made for this kind of work in the field and in the pack house to be able to increase the amount of data you collect to give you better data insights. When we're building models, and this is a kind of an important thing to touch on, it's essentially the same idea as doing quality testing in the pack house or in the field. We need to incorporate as much variability as possible to be able to predict accurately at any stage of the supply chain, in any region, for any cultivar, at any stage of maturity. So basically, when we're doing our data collection, we have to have all of these things in mind and collect the most robust data set we can possibly collect. And so that's what we do. So we go out and we find every major growing region we can get to, find farmers and find pack houses and organizations that are willing to help us collect data. And we go out there and we collect data throughout the entire season. And then we do that for another season, and then another season, and then another season, because seasonality also impacts the fruit, right? Things are going to change year over year. And there is a little bit of a cyclical aspect to that, where we can get away with maybe only doing 3 seasons or 4 seasons, and we'll have a good robust model. But for the most part, this model building never ends. And so we use that to our advantage. We try to make the most robust data sets possible. And when we're doing this, we are also simultaneously doing independent validation. So we're going out and we're testing it independently with new users and new farms, and making sure that it's working for them just as well as it is for the farms where we used it to develop the model. The other aspect of this is we incorporate AI, obviously, like everyone else is doing. Advanced chemometric techniques exist to allow us to build more robust models. So basically, turning the spectra into a quantitative prediction requires a lot of advanced mathematics. Those mathematics have gotten better through deep neural networks, machine learning, and things like that. So we use that to our full advantage when we're building our models. And just to give you guys an example here, a little case example of how variable a lot of avocados can be. This is just published data from a study that shows that how different dry matter can be within a single canopy. So this is just avocados that are from the same tree, multiple different canopies, and canopy positions. And you can see that, it's not just a case of all avocados are going to be 21% dry matter. It's all over the place. And so if you're not testing all those avocados, or at least a representative sample of those avocados, let's say if you just pulled 5 of them from that middle, you're not going to understand or know that this is a very variable lot of avocados. And so this is why this kind of sampling, this technique, this idea of representative data, big data, is so important across the supply chain right now. So basically what I was hoping to kind of get out of this talk and kind of explain to you guys is that we need to expand our data collection, and we need to get out of this mindset and shift our mindset from, we have to only abide by the standards of collecting 5 avocados and testing them destructively in an oven and call that good, and hope for the best that everything is going to work out for us in the end. And we need to move forward into thinking towards big data, towards using that to our advantage, but doing it in a smart way that's not going to, cause us any headache. And so that is exactly where this kind of measurement tool comes into play. And any kind of NIR, you'll see a lot of other NIR technologies out there. And this technology, the base technology, is a great one for this kind of data capture. And like I said, we just need to shift the mindset. More data is a better harvest, and it's better harvest timing. It's better consistency across the whole supply chain. And at the end of the day, it's better consumer trust. So that's the idea behind this technology and this thought process. So if you're interested in talking to me more about it, we have all of our instruments on display. We are also just around the corner, right here at Carbon. And we're at D33. If you want to scan that QR code, or if you just want me to send you the slide deck, or if you want to book a demo or come over to our booth and talk about it, feel free to talk to me after this. I'm more than happy to talk more about the subject. I could talk about it for hours, and so getting this down to 15 minutes was very difficult for me. So I'm happy to discuss some more, but thank you all.